Okay, so today we will study about fluid dynamics. Till now we did fluid statics. I mean, don't be too happy. We are not going to study any kind of flow. Why, sir? Because fluid dynamics is actually a very difficult subject. Difficult matlab for you right now. Later when you will do engineering and all, you will be better in mathematics, more rules, more knowledge you will have in maths, then you will be able to do those kind of difficult equations also. You will be able to solve. So here we are not going to study real flow of fluids. We are going to study uh, ideal flow, and that is what we call streamline flow. Streamline flow. Sometimes we also call it steady flow. So only this kind of flow we will be concentrating. And in real life, this kind of flow happens very rarely, especially when the flow is very slow. What did I say? Flow is very slow. That time we can consider streamline flow. So if you open the tap little bit, creating very small pressure difference which allows liquid to flow in a very smooth way, then we can consider it streamline. But as it falls, gravity will increase the speed, and after some time, as it falls, it will no longer be streamline. But we will be focusing only on what kind of flow? Streamline flow. Now the question is, what is streamline flow? Very simple. Imagine in this tube, some liquid or fluid is moving. So some liquid is flowing. Water in a pipe, you think, what is there? Now take any point in this fluid. When a particle of the fluid, so whenever a particle of the fluid is passing through this point, let's say its velocity is v, then all the particles passing through this point should also have velocity v, then it is streamline flow. So if at one point you know velocity of Akanksha, then all of you while crossing this point should have same velocity which Akanksha had at this point. So it's not like when Akanksha passes, her velocity is v this side. When Shreya passes, her velocity is v dash this side. Then it is called turbulent flow. What flow? Turbulent. Real flows are like that actually, when water will gush out. Understood? From a tap. So I'm not saying again Akanksha should have always this velocity. No. After some time when Akanksha will reach here, her velocity, if the pipe is like this, let's say, then when she reaches here, her velocity will be somewhere here. But the point is what? You understood? Tell me. All the other particles while crossing this point should have this velocity. In other words, the flow velocity at any point, at any given point, remains constant in time. Remains constant in time. Understood? Imagine there is a car which is moving with velocity, let's say 60 kilometer per hour, and here there is static air. Now from ground frame, if I see from ground frame, right now what is velocity of, let's say, this air particle at this point? Very far from the car. 0, because this air is static, I told, on average. So if you take some parcel of air, parcel matlab some element, then that fluid element is at rest. When this car will come and strike this, it will have velocity as car only, approximately. That means from ground frame, the flow of this air is steady or unsteady? Unsteady, because right now it doesn't have velocity. After some time it has velocity. What I told, velocity at any point should remain constant with time. So if I see this problem from ground frame, then the flow of air, right now this part of air is on average not moving. When the car will come and hit, it will have velocity. So velocity of this part changes with time. Then it is not steady flow. But if you study the motion of air from this frame, then this car will be at rest. Now this fluid element will have what velocity? 60 kilometer per hour this side. So for you, air will rush back like this. And for you, that flow will be steady, because all the other parcel of air while passing through this point will have 60 kilometer per hour only. This car will not go and hit here now, because we are studying the motion from car's frame, so car will be at rest for you. So all this fluid element while passing through this point will be steady flow. That means very interesting thing we learned. A flow can be steady for someone, same flow can be unsteady for someone else. That you remember, in later problems it will be useful. So the path followed by a fluid element, that path is what is called streamline. The path followed by a given element of the fluid is called streamline. Some properties of streamline you should know. If streamlines are closer, in a given region, then it means velocity there is higher. Why is this so? We will see little bit later in equation of continuity. What is equation of continuity? That is what I told, we will see later. But this property you try to remember. If streamlines are closer in a region, so if I show streamlines like this, then what does it mean? Here velocity of fluid is more, here velocity of fluid is less. So here flow velocity is more, here flow velocity will be less. That you try to remember. Second property of streamline is they don't intersect. Streamlines do not intersect. Why? If they intersect, then at the point of intersection, the fluid velocity can be either here or here. Because this is representing path. If this is representing path, what does it mean? Tangent to streamline will give you direction of velocity. Tangent to streamline at a given point will give velocity at that point. Gives direction of velocity vector at that point wherever you draw tangent. So here if you want to know velocity direction, you have to draw tangent. Now if two streamline intersect, how many tangents can you draw? Two tangents. That means fluid velocity can be either here or here. That's not possible in streamline flow, I told. At one point velocity should be same. It cannot be here also, here also. That's why streamlines cannot intersect. Example of streamline flow, if you want to see, is as I told, you have to make the flow very slow. One example is agarbatti, you know agarbatti. Light your agarbatti. Light matlab what? Just make it catch fire with matchstick. So this is your agarbatti. Now see the smoke coming. Initial part of flow will be streamlined. Initial part. But as you keep waiting, you will see this will start becoming more and more random. At any point, if one smoke particle goes here, another may go here. So that is because as it goes up, it mixes up with air, then diffusion and all will start occurring. Question of continuity. Basically, this equation of continuity is conservation of mass. Conservation of mass. What do you mean by conservation of mass, sir, here? So imagine you have a pipe which is something like this. Pipe where water or some liquid is flowing this way. Streamline flow, okay, streamline flow. All the flow considered will be streamlined unless I mention separately. So flow is this side. Now we assume this liquid is incompressible. Already we have done that assumption in fluid statics also. Incompressible basically means what? The density remains constant. Now focus. If I say here the cross sectional area is, let's say, A1, and here the cross sectional area is, let's say, A2. Now as the fluid will move, this cross sectional area, this red pink color part, will move this way. So let's say this one reached here after some small time t. If the velocity here for the fluid is v1, this distance covered will be what in time t? v1 into t. So this distance covered is v1t. That means how much mass came inside? Mass that came into the tube. In what time? T time. This mass will be what? Density into volume. This is what shape? Cylinder. Cylinder's volume is what? Area into height or pi r square h. Pi r square is the area. H is the this distance which is v1t. So area into distance. Distance is v1t. So this is mass which came in. Density into this is volume which came in. Everybody clear? Volume is pi r square h for cylinder. This is area. This is distance covered v into t. There the area is a1, velocity is v1. That's why I wrote like this. Clear everyone? Okay. During that much time when this fluid reached here, this fluid also should go there because this liquid cannot be compressed. You cannot compress it. So whatever mass came in, same mass should go out. So let's say this one reached here. Then how much mass came out? Let's say this here velocity is v2. Then what is this distance? In the same time. Time should be same, no? If you wait here 1 second and here 1 year, then in 1 year more water will come out obviously. What I am saying by conservation of mass? By conservation of mass, what do I mean? If you wait 1 second here and 1 second here, whatever mass came in, same mass should go out. You cannot create suddenly mass in the middle. Or suddenly mass cannot get lost. So what is the mass that came out? Density is same I told. What is the volume that came out? Area into distance. What is this distance covered? V2 into T. So area into V2 into T. Now we know that this mass coming in must equal mass going out. This is called conservation of mass basically. Substitute, what will you get? Rho A1 V1 into T, rho A2 V2 into T. So density gets cancelled, time gets cancelled. So what do you get? A1 V1 remains same as A2 V2. What this equation says? As the area of cross section changes, velocity also should change. So A1 becomes A2, V1 becomes V2, but product remains same. If product remains same, what does it mean? If this is 2, this is 3, then if this is 1, what should be this? 6. That means wherever area is smaller, velocity should be larger, higher. So this basically means A into V remains constant. That means V is inversely proportional to area of cross section. If you cross multiply, it will come in denominator. That means if the pipe has small area of cross section, water will flow there fast. It has to, because it has to cover same mass. Whatever mass came in has to go out. To keep mass same, volume has to be same. But here area is less. So to keep volume same, it needs more distance to be covered. To cover more distance, it has to move faster wherever area is smaller. You can try this in with garden, this hose. Pipe will be there, no watering, to water the plants. So from this pipe, water is coming out. Now you block some area. What do you see? It comes out faster. It will go with more range. Yes or no? So if you decrease the area, water comes out fast. That is equation of continuity. Something that you already know from common sense. Physics tells you in a nice mathematical way. After equation of continuity, we have something called BP, blood pressure. Hey, what blood pressure? Bernoulli's principle. Whose principle? Bernoulli's principle. So let us understand what is Bernoulli's principle. Like in simple way, equation of continuity is what actually, if you think, conservation of mass. Bernoulli's principle in simple way is conservation of energy. Conservation of energy. So first we will try to prove and then we will write statement. Again we will assume streamline flow. Second we will assume steady flow. I mean streamline flow here means steady flow only. Then we will assume incompressible fluid. Incompressible fluid means density everywhere will be constant. Because incompressible means you cannot change the volume for a given mass. So if you cannot change volume of a given mass, you cannot change density. But that is only our assumption. In reality, we can change little bit for liquids. For gases, though, we can change nicely. Then third is non-viscous. So this non-viscous part we will see later. What is viscosity? One separate topic is there. But just to get one small idea now, viscosity or viscous nature of liquid basically means the internal friction between the layers of liquid. When you stir water in a container with a spoon, in a cup with a spoon, and you leave it after stirring, do you think that rotation happens for whole life or after some time it stops? That means there may be some internal friction. That friction between the layers of liquid is called viscosity or viscous force. Right now we will assume there is no viscous force. Otherwise heat energy also we have to include. Some of the mechanical energy will go into heating. So heat I don't want to bring. Just like in mechanics we assume no air resistance. Like that. We will assume no viscous force. So non-viscous liquid. So these three assumptions we are going to do when we derive this formula. Once I derive the formula, then I will give you statement. So let us imagine water is flowing in a pipe something like this. So some design I created, okay, some pipe like this, and flow is this side. So some liquid or gas is flowing like this. Focus on this element or this part of the fluid at a given time. Immediately after some time, it will go here. Yes or no? And just now we learned whatever mass came inside, same mass should go outside. See, initially we considered this fluid. After some time, it became this. Basically, I can say since this part is common, this much mass from here reached here. It's like a ball which went like this up. Ball's mass remains same or different during its flow? Same. And we know whatever mass came in, same mass will go out. So we are going to apply work energy theorem to this element when it goes from here to here. We know from work energy theorem, work done by external force is delta K plus delta U. I hope all of you remember this. Sir, it is actually work done by all the forces is equals to delta K. From there only this comes, no? Work done by all forces means what? Work done by some external forces plus work done by gravitational forces is equals to delta K. Gravity is conservative force. So work done by conservative force can be written minus delta U. That will go that side. So this is nothing but work energy theorem only. What theorem? Work energy theorem. So this is from work energy theorem. Now tell me, here velocity if I say is V1, here velocity will be V1 or more? More. Just now we learned in equation of continuity, if area of cross section is less, here area of cross section is less, here area of cross section is more, velocity will be here higher. So what will be delta K? Half m V2 square minus half m V1 square. Change in kinetic energy of this element when it went from here to here. Everybody clear? Mass will remain same, I told. Whatever mass comes in, same mass goes out. What about change in gravitational potential energy? For that we have to measure height, and for height we need to choose our reference, and reference we can choose anywhere we want. Let us choose here. Let us choose here. So the center of mass of this, let's say, is at a height h1, and center of mass of this is at a height h2. Then what will be change in potential energy? mgh2 minus mgh1. Now we are supposed to calculate what? Work done by external force. Now who is the external force here? That is the question. By the way, did you notice potential energy increased? Did you also notice kinetic energy increased? Because velocity here is more. If potential energy also increase, kinetic energy also increase, pakka some work has to be done. If you allow this chalk to move only under conservative force, see what will happen. When it goes up, what happened? If it was moving only under conservative force without any external force, like this, external non-conservative force I mean, Gravity is also external for this chalk, but it is conservative, no? So if it moves only under conservative force, what happened? Potential energy increased, kinetic energy. That's why we say mechanical energy is conserved. But if I do like this, then I can increase kinetic energy also, potential energy also. But I have to do work. So here who is doing the work? Obviously the pressure force here. This element, this part of the fluid will feel force from this fluid. Here also fluid will be there, no? Or it may be some pump here, some pump which is creating high pressure. So the pressure force here will be what? Pressure force P1 into area. This is the force. What is P1? Pressure at this location. Similarly here pressure force will be like this. So here velocity is V2. Pressure force, let me color and show. It will be this way or this way? First way or second way? Pressure force. See, actually this is our system, don't forget. But we are not worried on change in kinetic energy of this part. Why? Because this part was there initially also, finally also. Similarly, I did not worry about change in potential energy of this part. Because this part is common, no? See. This was your, actually this is my system. Then I told the liquid is moving, so it will go here. This much part, before it was this much part. Then it became this much part. Now where is the common thing of blue and red? Here. So this part we can ignore while calculating changes because that remains same. At same location, same velocity. Only extra is what? This pink part has become this blue part. You can think that way. So it has gained speed, it has gained height. Correct or not? This is your system. Here pressure force will be this way. You have to search who is in contact with this, no. So this is in contact with fluid here and fluid here. Here normally it may be atmosphere. So atmosphere is pushing it this way. Pressure force is always pushing force, right? So if you take this as system, then pressure force here is this side. Here where will be pressure force? This side or this side? This side it will be, brother. Forces on the system we have to consider, no? So pressure force here will be this way. That will be P2 into A2. Here this is your pressure force, P1. So now let us calculate work done by pressure force. What is the work done by this pressure force? Force into displacement. What is displacement here in time t? V1t. So what will be work done? What is force here? P1 into A1. What is displacement? V1 into t. Now think carefully, who was this brother in equation of continuity? Volume. Volume that came inside. And volume that came inside can be written as mass that came inside by density. Density is mass by volume, so volume is mass by density. So this is why I wrote in terms of m, because everything I wrote in terms of m, no. So this work done also I want to write in terms of m. M and rho will be same, remember, don't write m1 rho 1. I told no, whatever mass comes in, same mass goes out. Now tell me, and this work is positive, remember. Why? Because force is this side, displacement is also this side. This is work done by pressure force P1. Now tell me work done by pressure force P2. What is force here? P2 in, let me write formula first. F2 S2. Minus or plus? Why minus? Because they are opposite, cos 180 will come. In work done, we have cos theta also. So what is the magnitude of force? P2 into A2. What is distance covered from here to here in same time? V2 into T. In equation of continuity we saw already. What is this? This is area, this is distance. What is area into distance? Volume that went out. What is volume that went out in terms of mass? Mass by density. Because already we know A1 V1 is equals to A2 V2. This we already proved last topic. If I multiply with time, this becomes volume that came in, this becomes volume that went out. And volume that came in or that went out can be written as mass by density. Mass that came in or out. So in place of A1 V1 T, I can write m by rho. That is what I did here. A1 V1 T m by rho. A2 V2 T m by rho. So what is the total work done by external force? P1 m by rho minus P2 m by rho. This is the total work done by the external pressure force. Now substitute all this in work energy theorem. Putting equations 2, 3 and 4 in equation 1, which is your work energy theorem. What we will get? What is the work done by external force total? P1 m by rho minus P2 m by rho equals, what is kinetic energy change? Half m V2 square minus half m V1 square. What is delta U? Change in gravitational potential energy. mgh2 minus mgh1. What we can do with m? What we can do with m? Okay, take common and cancel. That's because this m, I could have taken time t till here also. So that m should cancel anyways, because your answer should not depend on my imagination. If I imagined this much water came, then same amount of water will go out. But you may imagine this much water came in. So that imagination should not change your answer, no, the final result. So it should be independent of m. Therefore m has to cancel. You can choose whichever m you want in exam. Now bring all the 1 ones together. What will you get? P1 by rho. Where is 1 1 now? That side you can see 1 or not? Bring it this side. What will you get? Plus V1 square by 2. Then GH1 is there with minus sign. Bring it here. Plus GH1. Take 2 to that side now. Minus P2 by rho, take that side. What will you get? P2 by rho. Next step, next term. Plus V2 square by 2. Next term. Plus GH2. This equation is called Bernoulli's principle. If 1's remain same as 2's, what does it mean? When we write K1 plus U1 equals to K2 plus U2, what do we say? Mechanical energy is conserved. Here, what is conserved? What is this, do you think? If I ask you to name this, what will you name this? What will you name this? What is the name of this? Don't know. If you call this kinetic energy, what will you call this? What is this? If I ask you, what is this? Huh? Rate of? Suppose I remove this. What will you call it? Rate per unit apple. Per unit apple, because you are dividing by number of apples. What is this? Kinetic energy of some fluid of whose mass is m. If I remove this, kinetic energy per unit mass. So this term is kinetic energy per unit mass here. This is kinetic energy per unit mass here. What is this? Potential energy per unit mass, mgh without m. So kinetic energy per unit mass, potential energy per unit mass. Then who should be this? This also should be energy per unit mass, because in units and measurement we studied, apples cannot be at, see, after long time it came, right? Mangoes cannot be added with apples. Mangoes can be added only with mangoes. So if this is joules per kg, what should be this? Joules per kg. We have a new name for this. We call it pressure energy per unit mass. So V square by 2 is kinetic energy per unit mass. GH is potential energy per unit mass, and pressure by density is pressure energy per unit mass. So the sum of these three terms should remain constant. So in fluids you have a new form of energy besides kinetic and potential. It is called pressure energy. What energy? Pressure energy. Therefore, finally what I will say? I will say P by rho plus V square by 2 plus G into H. That remains constant throughout the flow. Throughout the flow. Throughout the flow means for any 2 points. But remember, those 2 points should be joined by the same streamline. Like in our question, this, if you remember this pipe system, this point and this point were joined by same streamline, yes or no? Then only you can apply Bernoulli's principle between those 2 points. Density should be same everywhere, remember. So one of the applications of Bernoulli's principle is Torricelli's law. Torricelli's law. So what is this Torricelli's law? Let us try to understand. Let's say you have a big tank, open tank. So two things are important. It should be open tank and it should be big tank. Big. Big is relative, no? It may be big compared to me, but it may not be big compared to earth. So what do you mean by big, sir? So when I say big, I mean it's this area. If I say this area is A1, capital A, let's say, I will keep changing the symbols. So if this area is capital A, I am going to make a hole here. So this area is small a. Or let me write A1, A2. So when I say big tank, I mean this A1 should be much larger than A2. That's the meaning. So this is our assumption. This is what is normally true in tanks and all. When you make a hole, tap, you will connect this hole to a tap. Now let us put water. This is the water surface, let's say, or some liquid. Now you know from this hole the water will come out with some velocity. That velocity we want. How much velocity it has when the water comes out from the hole. So we will apply Bernoulli's principle between 2 points in this liquid. Which 2 points I can choose? Any 2 points in the fluid I can choose. Let me choose 1 point here. 1 point just outside but on the liquid. You have to choose on the liquid but outside. Not here. Here. That's very important. Here, that difference is there. I can I can apply Bernoulli's principle between this point and this point also. But let me apply first between this point and this point. First check same streamline connects these two or not. Same streamline connects these two as the water comes out. Now, what is Bernoulli's principle? P1 by rho plus GH1 plus V1 square by 2 equals P2 by rho plus GH2 plus V2 square by 2. Kinetic energy per unit mass, potential energy per unit mass, pressure energy per unit mass. Just now I proved density is constant, G is constant, so don't write G1, G2, rho 1, rho 2. But height can change, velocity can change, pressure can change. Let us now discuss what are the values of pressure, height and velocity at these 2 points. Now look carefully. This point is open to whom? Atmosphere. So pressure here will be what? P atmosphere. Now height H1 that we write depends on your reference. Where I will choose reference? I will choose reference here itself, wherever is the hole. You can choose reference wherever you want. If you want, you can take reference here and solve. I will choose where? Wherever is the hole, there I will choose reference. So if I choose reference here, then what will be height here? This height. So now tell me height of this point from reference. Height of this point you tell from reference, H. So this will be GH. Now comes a very important fact. You know from equation of continuity, A1 V1, matlab the velocity here, that must be equals to A2 V2. But I wrote A1 is much larger than A2. That implies V1 will be much smaller. So since here we are, if I bring that V1 square that side, I am subtracting V2 square by 2 with V1 square by 2. Already I know V1 is very small. So V1 square will be what? Even more smaller. 2 is less than 10. 4 is even less than 100. So therefore, in this principle, we can neglect V1 only because we assume what tank? Big tank compared to the area. You can see this in life also. Open the tap, see the water in the surface, in the tank. You will see it goes very slowly down. Here it comes out very fast, but here it goes very slow. Expected also. Because what we learned in equation of continuity, volume coming in should be equal to volume going out. Now volume is area into distance covered. Here area is too big, so distance covered will be very small, whereas here it will be very large, the velocity, which is nothing but displacement per unit time is velocity. So here velocity is very high, here velocity will be very low. That means V1 can be neglected. Compared to whom? V2. That is important. I am not saying this is really 0. If it was really 0, this surface will not come down only. If it doesn't come down, then how this water will go here? So of course this surface is coming down, but the speed with which it goes down is extremely small. So in this principle we can ignore, because in this principle we are going to subtract this big term with this small term. Okay. So since V1 is very very small compared to V2, V1 will be taken approximately 0 in Bernoulli's principle. Okay. What about P2? Pressure here. Just outside I have chosen. But touching the water, but just outside part. What is the pressure? Open to atmosphere. If you choose here, you cannot say atmosphere. That's why I am telling. You have to choose one point just outside, one point here. If you want, you can choose one point here, one point here. I can show you that way also if you are interested. But if I choose here point, then I cannot say pressure here is atmosphere. It will be atmospheric pressure plus rho gh. That we know from our hydrostatics. But if you choose this point, you will not get this V. You will get this V1, because this area is same as this area. That area is same as this area. So here the velocity of flow is same as V1. So that is very slow, but this velocity is very high. So if you choose one point here, one point here, you will never be able to calculate this V, because you will calculate this V1 only, which we have already neglected. Clear or not clear? Because this area, this area, this area is same, so velocity here, here, here will be same. Forget these things, ma. Okay. So what is P2? Atmospheric pressure. What is height of this point from our reference? How much? 0, because I have chosen reference there only. And what is velocity at this point? That is what we want to calculate. Correct, students? Now this is 0, this is 0. These two will cancel. So GH will be V square by 2. What will be V? Square root of 2GH. This reminds you of free fall velocity. So if you drop a stone here, by the time it will reach the hole, it will have this velocity only. That is Torricelli's discovery, that he found that the velocity of fluid through the hole is same as velocity of some body drop outside, of course, free fall it should be, so if you drop outside from the surface till it reaches the hole. So whatever velocity it gains during free fall, that velocity is same as velocity of the fluid, and this is called velocity of efflux. This water coming out from here is the flux of water, the outward flow. Flux word means outward flow. Outward flow. But you should just remember that when water is kept in a tank and a hole is made, the speed with which water comes out is square root of 2gh. What is h here? Very important to understand. Is h height of the tank? Is h height of the surface of water from the bottom? It is height of the surface of water from the hole, or you can say depth of the hole. Depth of the hole from the surface. So this is h. Tumba important. Don't forget. Okay. So what I am going to ask you people is, let's say there is water till the top of this tank, open tank. This height right now is h. Question is where I should make hole so that when the water will touch the ground, this range should be maximum. So find y so that r is max. This water will come out from here, no? Once you make hole, that velocity will keep changing or will remain constant? Keep changing, because this level of water will keep coming down. It may come down slowly, but it will come down. What was the velocity of efflux? Under root 2gh. h was the height of the surface from the hole. So that height keeps on decreasing. Whatever it is, question is, if I make hole now, it will have some velocity v. It is like what projectile now? Once it comes out, it is like horizontal projectile. So it will reach the ground like this. So we want this r to be max. So let us write formula for this r. Before that, tell me what will be this height? H minus y. And what is this v from Torricelli's law? Under root 2g y. Now in projectile motion, if this is u, this is h, this is r. Who remembers relation between these three? So many problems we did. R equals to u, tell. Okay, tell me h in terms of r and u. This one we used to write more. H was half g t square, t was r by u whole square. This was h. So r, if you want, you have to cross multiply ux into t. T is under root 2h by j. From here to here, can you see this is displacement? So if this is displacement, this is your sy, this is your sx. That too you know, I think, from vectors. Or shall I revise vectors also? Now what is sx? Ux into t. Along horizontal there is no gravity. So there is no ax. What is ux? U cos theta. But here u is horizontal only. So theta is 0 degree. So u cos 0 u. So ux is u. Sx is r. So this is first equation. Sy formula is what? Uyt plus half ayt square. Here there is no uy. Why no uy? It starts with what velocity? Parallel to x. So what will be y component? So if uy is 0, what will be sy? Huh? What? Saying t. You understood why he said t? Because s equals to ut. U is not there but t is there. Nice mathematics, ma. Some new zeros, new nature you discovered. See, it may be right. I mean, one day, I don't know. See, in science, no, anything can be right, ma. You have to just allow it to grow. So, till you publish some papers and all to prove that 5 into 0 should be 5 because 5 is there. This is 0, but 5 is there. No, how it is 5 into 0, 0. So, until you prove that, we cannot write t, okay? Because uyt is 0. That's it. Huh? So, sy is 0. Half. Gravity is also not there. So, half ay. What is ay? G. What is sy? H. So, from here what is t? Square root of 2h by g. Substitute this t here. Now understood? So, what is this r? U into square root of 2h by g. But in this problem, what is u I have written as v. And h was this height, not this height. In projectile motion, this is your h, this is your r. Here what is h? Capital H minus y. Clear or not clear? What is v? Root of 2g y into square root of 2h minus y by g. Root g we can cancel. So what will be r? Square root of 4y h minus y. So this is your range. Now they want this range to be what? Maximum. For any function to be maximum, what we learned in calculus? For r to be maximum, if any function y is maximum or minimum at some point, what does it mean in calculus? Punit? Very good. The differentiation of the function should be 0. If you draw a graph of y versus x like this, at this point if you ask slope, it is positive, and slope at a point is nothing but dy by dx, because slope is tan theta. Tan theta is opposite by adjacent. So at this point if you draw a tangent and make a right angle triangle, this will be your dy, this will be your dx. So dy by dx is tan theta. Yes or no? So here the angle is acute. Tan of acute is positive, or you can say y is increasing. So dy by dx will be positive. If your function is increasing, the change is positive, right? If your height increases, change will be positive, no? More minus less. If here what happens to your y? Y decreases. So what will be dy? Negative. Dx though is positive only, because x we are increasing, y is decreasing. So here if I draw tangent at this point, slope will be what? Here slope is positive, here slope is negative. So in the middle what should be slope? If you go from plus to minus, somewhere you have to cross 0, right? So at this point what is dy by dx? Dy by dx is 0. Y is what? Maximum. So when your function is maximum, it will not change at that point, because it is maximum. Maximum means you cannot increase more, no? If a function is maximum, at that point it cannot further increase. Same thing will happen if there was minimum. At this point, y is what? Y, minimum. What is dy by dx? 0. So, for r to be maximum, this quantity here should be maximum. So, for r to be maximum, y into h minus y should be maximum. Because 4 is constant. If this should be maximum, differentiation of that should be what? 0. So why with respect to y? Because y is the variable. No, we have our aim is to find this y only, where r will be maximum. You can do this also. You can make dr by dy equal to 0, but then you have to do differentiation for square root. Unnecessary, because if this is maximum, this is also maximum. So why to take differentiation of r? We will take differentiation of this itself. It will be easy to calculate. What are the two terms of the differentiation here? Y into h minus y square. Tell me differentiation of first term. H will come outside, no? Dy by dy will be what? Minus. Second term differentiation you tell. Dy square by dy you tell. That means where I should make whole? Where I should make whole? H by 2. Matlab where? At the middle. Not middle of the tank. Middle of the height where you have put water. Now if you have put water till the top, then it's okay. There is a tank like this where water is up to here, let's say. If you make hole exactly in the middle, what did you learn? Velocity is not maximum, range. Velocity is maximum here. But then it will not go only. It will just stay on the surface only. You need height also, no, for range. So if you make hole here, that time the range will be maximum. What if you make hole here? Here or here? You will see it will go like this. If you make it exactly same distance, it will be exactly same here. So maximum will be when you make the hole where? Middle of this height. At least do this experimentally at home. Now we will discuss something called siphon. How many of you know siphon? Is, let's say there is a tank or some beaker. Why every time tank and all? Beaker also you can think with water or some liquid. Okay. Now you put here some pipe. The important thing for the siphon to work is the mouth of this pipe should be below this surface. Very important. Where should be this? Below this surface. If this is above this surface, it will not work. Now what you have to do? Put your mouth here and suck the water. It is important that water is filled everywhere first. If you suck till here and then leave, it will not come, it will not flow. Understood or not? You have to make sure the water is completely filled. Then you let it go. After that, it will continuously flow. Of course, continuously flow means still this whole water will be here. Once whole water will come out, what air also you will take out. Or if the tank was still here, let's say, then till the water is here, it will come out. Once your water level will go below this, it will not come out. You will see in the formula only. So the first question here is, so siphon working you understood? Full working now you will understand. But question is, what is the velocity of the water coming out from the tube? That is the question. Again what we will do? We will apply Bernoulli's principle. So we will choose 2 points. Which are the 2 points we will choose? Don't choose this point. If you choose this point, there also their velocity will be v only. Because this area is same everywhere. So instead of choosing this point, choose this point. One here, and then we will go this streamline. This is the second point. So first point is this, second point is this. Are they connected by same streamline? Yes, I can search for one line which is through the same liquid. Correct? Let's apply Bernoulli's principle. Directly shall we apply, or you remember formula? First tell formula. What is Bernoulli's principle formula? P by rho plus GH plus V square by 2 remains constant. Between 1 and 2, I will apply Bernoulli's principle. Between 1 and 2. P1 by rho plus V1 square by 2 plus GH1 equals P2 by rho plus V2 square by 2 plus GH2. One is open to atmosphere. What pressure? Atmospheric. So this is atmospheric. Acha, in previous case I forgot to show you between this point and this point. Shall I show you fast and show you same answer? Same answer will come here. See, P1 by rho. Here P1 you tell. P atmosphere plus rho GH. This is H, no? So P atmosphere plus rho GH is P1. P1 by rho plus GH1. GH1 matlab height from reference. I will choose height 0 here only. So GH1 0 plus V1 square. This velocity here is same as this velocity because this area is same as this area and that velocity is negligible, I told, is equals to P2 by rho. P2 here is P atmosphere plus GH2. This is also at reference. So GH2 0 plus V square by 2. Can you see same answer will come? P atmosphere by rho cancel. Rho GH by rho cancel. GH equals to V square by 2 cross multiply V equals to root of 2GH. Same answer. So I can choose these 2 points also to derive velocity of efflux. Okay, so this P1 is P atmosphere. What about P2? P atmosphere. That means these 2 terms will cancel. This area is very large compared to this area. So V1 square can be also taken approximately 0 because area of the tank is much larger than area of the hole. All these you write reasons, then only you will understand clearly when you revise. So this is 0. What is left? Now GH1. Height 0 where I will choose? Height 0 I will choose here. The mouth of the pipe. There I will choose height 0. Then what is the height of this level? H. What if they give this as H1, this is H2? Then what will be this H? H1 plus H2. Be careful. You have to always measure H from reference. Reference you can choose wherever you want. I normally choose the lowest point. So this is the lowest point in my diagram, in my motion from 1 to 2. So I choose height 0 here. So what will be height of this point number 1? H. V square by 2 plus what is GH2? Height of this point, height 0. I have chosen point 2 at height 0. So height of point 2 will be 0. So what is V? Square root 2G. Meaning same answer as Torricelli, but there it was what? Depth of the hole from the surface. Here depth of the mouth of the pipe from the surface. It makes sense also because there it was coming from the hole. No, here the water is coming out from the mouth of the tube. So that this depth matters. That's why I told you this should be below this level. If this goes above this level, H will be negative. If you take this H positive, this H will be negative. Negative under root will be imaginary. So if your mouth is above this level, it will not work. Now one very interesting question is there. Even if this point may be below this point, there is a chance water may still not come out. If this height is too large, so we will try to find what should be the maximum value of this. So find maximum value of this. What I should call this height? Height of the crest. This is called your crest of the pipe. Your pipe will go like this, no. So there will be crest at one point. So how high that crest of the pipe should be from the surface so that this siphon will work. So find this so that siphon will work. So this is second question, okay. First question was to find V. That we did. Can you guess what will happen if this is too high? And that pressure will keep decreasing as you go up. And if the pressure becomes less than 0, then it has no meaning. There has to be some pressure. No, you can't. Actually, we should not say 0. It should not be less than something called vapor pressure. If it becomes less than vapor pressure, no, then the liquid will boil. That I will teach you in next chapter. Do you know if you take water bottle in moon and open it, what will happen to the water? It will boil. Now tell me how. Water boils normally at what temperature? But that is at normal pressure. When the pressure outside is 1 atmosphere, that time it boils at 100 degrees. If you decrease the pressure, like you go to top of mountains, Mount Everest and all, there you try to boil. So when vapor pressure decreases, water will boil at lower temperature. So at 30 degree only water may boil. That's why your food will not get cooked nicely at high altitudes. Because at 30 degree only it is boiling. More temperature means more molecules are moving faster, so more soft the food will become. At higher temperature, 30 degree only it started boiling. The temperature is not enough. In pressure cooker, you are increasing pressure, so it will boil at even higher temperature. So food will become soft faster. Understanding? So in moon there is no atmosphere only. So any temperature it will boil. So the pressure here should not become less than vapor pressure, otherwise our liquid will boil. So now we will apply Bernoulli's principle between 1 and 3 here. Any point here you can choose. I have chosen this. Is it okay? So now I will apply Bernoulli's principle between 1 and 3. Chalo, let us start. Here pressure P atmosphere by rho plus V square by 2 is approximately 0 I told. I will choose height 0 here because I am choosing between 1 and 3. Sir, in same problem how you can change reference? I can change because first I studied between 1 and 2. Now I want to study between 1 and 3. If you want, I can keep height 0 here. Then I have to put this height and this height. Okay. Let me choose height 0 here if you are confused. Then tell me height of this point number 1, h. So G h equals to. Now you tell me pressure here, that we don't know. P3. Don't tell P atmosphere. It is not open to atmosphere. That is our clue. Pressure there should not become less than vapor pressure, which we will assume 0. So P3 by rho plus V square by 2. Here V will be same as here V because this is same area. If area is same, flow of fluid velocity will be same. So here flow velocity will be V only. Plus G, what is the height of this point? H dash plus H. See, you only wanted to choose height 0 here. If you have chosen height 0 here, immediately H dash will come. Now ultimately answer will be same because this GH and this GH will cancel. That's why I told, no, height 0 you can choose anywhere you want. Achha, so this will give me P atmosphere by rho, P3 by rho plus GH dash. So this V square by 2 also should be there. So let me multiply with rho. So P atmosphere will be P3 plus rho G H dash plus rho V square by 2. So what is P3? P atmosphere minus rho G H dash minus rho V square by 2. Now for this to work, if you want to keep siphon this way and work, then what is V? We found root of 2G this H, substitute that V here. So P3 will be P atmosphere minus rho G H dash minus rho, what is V square? 2GH, no, so GH. Because this V square is 2GH. For which siphon to work? For this siphon to work, this particular siphon. Why sir particular siphon you are saying? Because you have chosen this point this much below this point. Some other student can take this here also. Then this H will be different, so this term will be different. However, how much minimum you can make this? Minimum you can make this up to here. Up slightly below this, I know. This point should be below this point, no, I told. So H can be minimum how much? 0. For siphon to work, for this particular siphon to work, this pressure P3 should be greater than the vapor pressure. But here we will assume it should be positive. So this is actually, it should be vapor pressure, which I have taken how much guys? 0. What is P3? P atmosphere minus rho G H dash minus rho G H should be greater than 0. Take this one that side because our aim is to find H dash. So P atmosphere minus rho G H should be greater than rho G H dash. Divide by rho G. So P atmosphere by rho G minus h should be greater than h dash. That means h dash should be what? Should be h dash less than this. If h dash should be less than this is what h dash. Suppose 10 is greater than x. What does it mean? Any value of x should be less than 10. So 10 is what value of x? Max value. So more than that it should not be. That is what I was telling you before. This height cannot be more than a certain number. If it's too high, siphon will not work. So what is the maximum height of the crest of this pipe so that siphon works? The maximum value of this. So h dash max will be what? P atmosphere by rho g minus h. Now I told you this h, that h will depend on your setup. How much? If this h is lesser now, lesser, this will be even more higher. That means if somebody takes this point here, you can go even more higher. But you cannot take this one so much less, you cannot make this h less than 0. So let us calculate the maximum possible value. Possible value, this is possible. Sir, what is this? This is also maximum, this is also maximum. See students, this is maximum height possible for this setup. Now by decreasing this, you can go even more higher. But how much you can make this minimum? 0. So that time the maximum possible value of this crest for any siphon, that is. This is for which siphon? Only this siphon, whose this point is h below. Now I am telling you what should be this height maximum for any siphon. Because for any siphon to work, this h has to be greater than 0. Minimum it can be 0. Matlab this mouth has to be slightly below here. So the maximum possible height for any siphon to work will be P atmosphere by rho g minus 0. Because you can make this minimum 0. P atmosphere value all of us know approximately 10 to the power 5 Pascal. 1 atmosphere is 1.013 into 10 power 5 Pascal. Density of water, suppose this is water, suppose, assume. Normally we will take water only out. What is water's density? 1000. G value 10. So 10 meter. So for any siphon to work properly, the height of this maximum value of this height should be what? 10 meter. Matlab it should be less than 10 meter to work. More than 10 meter if you do, no siphon will work. So I told you then that when water comes out through their pipe, whether you choose this area or this area, A into V is what I told, constant. This area into velocity or this area into velocity, that product is called rate of flow. Rate of flow here means volume rate of flow. Matlab how much volume comes out per unit time. How, sir? How area into velocity is rate of flow? Anybody understood? What is volume of liquid coming out? I told. Area into Vt. Distance covered. Forgot, Vt. This is area, this is area, this is volume. Of course, it will depend on time because water keeps on coming out. So the more you wait, more water will come out. It's not like cricket ball is coming out. If cricket ball comes out, that much mass comes out, finish. But when water flows in a pipe, continuously mass keeps on coming. So what is the amount of water coming if they ask? That will depend on time also. Now, this is volume coming out. What about rate of flow if they ask? Rate of flow means what I told. How much volume comes out per second. Per second means you have to divide by time. Suppose 10 meter cube comes out in 10 seconds. Then what is the rate of flow? 1 meter cube per second. You have to divide by 10. What will you get if you divide volume by T? A into B. So please remember, area into velocity represents what? Volume rate of flow. Question number 97, once you see everyone. A square hole of side A is made at a depth h below water surface. So below water surface at a depth of h, they have made a what hole here? Square hole. So this is a hole but it is square. What is the side? A. Understood? Like from here if you see, it will be like this, no? Yes or no? So the hole that they are making is square hole. Square hole. Okay. Another circular hole of radius small r is made to the same container at a depth 4h. So at a depth of 4h, they have made a circular hole. What hole? Circular hole this time. What is the radius of the circular hole? R. Radius is small r. Here what was A? Side of the square hole. Side. What is this depth? 4h. What they want? It is found that volume flow rate matlab volume of water coming out per second divided by time, that is same through both the holes. So whatever volume of water comes out from here and whatever volume of water comes out from here, per unit time is same, rate of flow is same. Then what is the relation between this radius and this side they are asking? Radius of this hole, side of this hole. Here it is square hole, here it is circular hole. So according to question, volume rate of flow is same through both the holes. Volume rate of flow is same through both the holes. Let us say first hole is this, second hole is this. Now if volume rate of flow is same, what is the formula for V by T? Just now I told, area into velocity. This V is volume, this V is velocity. This A represents area. Let me write capital A. Because small a here is not area. Here small a is what? Side. Now tell me what is the rate of flow here. Let's say velocity here is V1. Then it is area here into velocity here. What is rate of flow through this hole? Area in the second hole, area of second hole into velocity of flow of water in the second, through the second hole. What is area of this hole? A square. What is V according to Torricelli's law? Root of 2gh. H matlab depth of the hole from the surface. From the surface, what is the depth of square hole? H. So this is root of 2gh. What is this area? Area of this hole. Circular hole they told. Pi r square. What is velocity of fluid here? According to Torricelli's law, square root of 2g into what is the depth? 4h. So this will be a square root of 2gh pi r square. Square root of 4 will be 2. Remaining is root of 2gh. This and this will entirely cancel. So what will be a? Square root of 2 pi into r. So r will be what from here? A by root 2 pi. Option D, no. See question number 98. A hole is made at the bottom of a tank filled with water. A hole is made at the bottom of the tank. Let's say here. You can make here also. Same thing. Height will be h, no. Let me make it here. They told bottom of the tank. The water's density is given 1000, that we know already from our previous knowledge. If the total pressure at the bottom of the tank, here the total pressure at the bottom of the tank is 3 atmosphere, then the velocity of efflux will be how much? Velocity of water coming out from here, that we know from Torricelli's law, root of 2gh. H matlab this depth. Only thing we have to calculate is this h. This h we can calculate because pressure here is given, and we know pressure at the bottom is pressure at the top, which is atmospheric pressure plus rho g h. What is pressure at the bottom? They told 3 atmosphere. Now 1 atmosphere in Pascal is how much? 3 into 10 power 5. We have to use SI units, no. 1 atmosphere is exactly 1.013 into 10 power 5 Pascal. But here approximately they told us to take 10 power 5. So what is the actual pressure at the bottom? They told 3 into 10 power 5. What is atmospheric pressure? Atmospheric pressure no one will tell you. You have to remember is 1 atmosphere. 1 atmosphere means 10 to the power 5. Plus density of water 10 power 3 G, I will take 10 H. This will come here 2 into 10 power 5 is equals to 10 power 4 into H. So H will be what? 20. Once we know H, what is the velocity of efflux? Square root of 2gh. Square root of 2 into 10 into what is H? 20. 400 square root is 20 meter per second. Which option? Sometimes the tank may not be open. It may be closed tank. Then pressure here you cannot take atmosphere. Either they have to give, or they may give sometimes no, some weight they may connect, weight. M, mass M, piston they may put on top. How will you find pressure here now in that case? So this piston we will assume is in equilibrium. Now ask why it is in equilibrium. Due to pressure here there will be force P into A. Due to atmosphere here, outside is atmosphere, there will be pressure P atmosphere into area plus mg. Now if the piston is at rest, P into A, upward force should balance P atmosphere into A plus mg. So what will be P here? P atmosphere plus mg divided by A. So this P you have to use in Bernoulli's principle between this point and this point. So the point I am trying to say is, imagine there is a tank and here there is a hole. As water comes out with velocity v relative to the tank, this is velocity of water relative to the tank. So if tank is at rest, then no problem. You can say this is velocity of fluid with respect to ground also. Anyways, so this is velocity with which water comes out. Now, the thrust force is given by Newton's second law, which is dm, relative velocity of the fluid coming out, into dm by dt. How to understand this formula? Simple. In time dt, the liquid may go till here, from here to here. With velocity v it is traveling. So in that time what will be this distance? V into dt. Just like before we wrote v into t. If this area of cross section is A, what is the volume of this cylindrical part of the fluid? A into V dt, this is volume, multiply with density. What will be that? Volume into density. What is volume into density? So this is the mass of the element that comes out. And that into velocity, you can think as change in momentum. It started with 0 speed, it goes to V speed. So dm mass went from 0 speed to V speed. So its momentum changed by this much. Mass into final velocity. Initial velocity is 0. Change in momentum divided by time. That is your force. From which law? Newton's second law. So this is the thrust force on the liquid, on this part of the liquid. Now if liquid is feeling this much force from the tank, tank will feel what force? Same force in opposite direction, that you remember. So this is also the reaction force. So as a fireman, let's say you become a fireman. So somewhere it caught fire, you are trying to put water in that. So as water comes out from this pipe, you have to hold this tightly because there will be a reaction force. The faster the water comes out relative to the pipe, the more will be the thrust force. Let us now calculate the thrust force. That will be V. What is dm by dt from here? From here. Tell me. AV rho is equals to dm by dt. dt you bring this side. I hope you understood how I found this. This is the volume that comes out in what time? dt time. If you multiply with density, that is the mass which comes out in dt time. So this much mass of water came out in dt time. And its velocity went from 0 to v. So clearly it felt this much force according to Newton's second law. So the thrust force is V into what is dm by dt? A V rho. So what is thrust force? Rho A V square. Very popular formula. Now this concept we can apply for this question number 107. In 107 what they told? Listen carefully. There are two identical small holes. Identical small holes means what? Area will be same. On the opposite sides of a tank. So there is a tank like this. Here there is a hole at what height they have not given, but these two holes, this height gap they have given, this height difference is h. Here water will come out, here water will come out. Here velocity is v1, here velocity is v2, let's say. As liquid comes out from the holes, the tank will experience a horizontal force proportional to how much they are asking. So when this water comes out, this tank will feel reaction force here, I told. This is the reaction force. How much is that force I told you? Rho area of hole into V square. What is V here? V1 square. Now from Torricelli's law, what is V1? If I say this depth is H1, V1 will be what? Root of 2gh1. So what will be V1 square? 2gh1. Because it is square, so square root will be removed. Similarly, when water will come out this way, tank will feel reaction force here. What will be that reaction force? Density same or different here and here? Area of the hole? Identical hole they told. So area will be same. Of course velocity will not be same because this is at more depth. Let's say this depth is h2. of the hole from the surface. Then what will be velocity square? V2 square. What will be that? Root of 2gh2. Square it. 2gh2. So net force will be what? F2 minus F1 or F2 plus F1? Net force. Minus, because they are in, those two forces are in opposite. Which force will win? F2 will win because this depth is more. H2 is more. So it will be F2 minus F1. That will be what? 2 rho Ag common H2 minus H1. What is H2 minus H1? The H which they gave in the question. So the force is proportional to what? H. Which option? Option C. Question number 108, you see, a jet of water delivering 0.6 meter cube of water per minute. So volume rate of flow V by T is given 0.6 meter cube per minute, which means 0.6 meter cube by 60 seconds, which means 0.01 meter cube per second. That is the volume rate of flow. This much water strikes a vertical wall. So there is a vertical wall. Water strikes like this with some velocity v, and they told if the water does not rebound. Water does not rebound matlab it heats and then just falls straight down. So after heating, there is no momentum along x direction. It can rebound also. If it rebounds elastically, if they say, then what does it mean? It hits with v, comes back with minus v. Minus v matlab v in opposite direction. But here they told it does not rebound. So it hits with v and stops, then just falls vertically. They want you to find force exerted on the wall. So this force we will calculate using the same knowledge like before. In time dt, this portion will reach here, let's say. Then this distance will be what? V into dt. If I say this portion reaches here in time dt, some portion will reach the wall, no? I don't know which portion, just I am assuming. So if this portion reaches here in time dt, this distance will be what? V into dt. That means this much mass will hit the wall in time dt. So this is change in momentum by time taken, Newton's second law. Now dm mass is coming with what speed? V speed. So what is its momentum? Dm into V. After hitting, what is the speed? 0. So that will be minus 0 by dt. What if it rebounds with the same speed? Then here what will add? Minus dm into V. That will become 2 dm into V. And what is dm? Density into volume. How much volume hits? This much volume hits. That is area into distance. What is distance? V into dt. V by dt. Dt cancel. So what force it feels? Rho a v square. So what is the force formula we found? Rho a v square. Now students, density of water they will not give, I told you have to remember. Area they have not given. But we know what is the formula for volume rate of flow? A into V. So I can write this rho A into V. And this A into V is what? Volume rate of flow. Finished. So density is 10 power 3. Volume rate of flow is given 0.01. Velocity is 25. That will be 250 Newton. Okay.